Hey guys, this is probability day 4. This is our last day of probability and actually our last lesson for the whole quarter, for the semester, for the year. You are all done after this one. You just have the probability test or probability quiz that I'm going to open up on Friday. So this is it. This is all the content. So good job, you guys. We made it through. So for this last video, we are talking about fundamental counting theorem. So it's a way to find the total number of options that you have for a certain situation. Okay, so there are a couple different ways that you can do it. And the first way that we're going to look at is creating a tree diagram. So you're ordering a pizza and want to know how many different options you have. There are 2 sizes, large and medium. There are 2 crust types, deep dish or thin, and then 3 toppings, sausage, pepperoni, or cheese. So we're going to create a tree diagram and find out how many options there are. So the first option that you have is picking the size. So you've got large or medium. So I could pick large or I could pick medium. Okay, and then once I pick that, I have 2 crust types that I could have. And I could have deep dish or thin. So if I pick a large, I could have deep dish or thin. Or if I pick a medium, I could also have deep dish or thin. Okay, so from each one, you're like branching off each time to figure out how many choices you have. And now we have, so we just did our 2 crust types. Now we have 3 different topping choices. So here we have size, here we have crust, and then the last one we're going to do is the toppings. So from each one here, I have 3 choices. So if I choose a large pizza that's deep dish, I can choose sausage, pepperoni, or cheese. If I choose a large pizza and have a thin crust, I can also pick one of those 3. Sausage, pepperoni, cheese. Same thing here, sausage, pepperoni, cheese. And those are our toppings. Okay, so now I can look at how many different options do I have. And the tree diagram, you have to go, it's almost like each branch that we're going down, right? So I have 1 here, large deep dish sausage, large deep dish pepperoni, large deep dish cheese. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can just count the ones at the bottom too. So I have 12 options. So I can always create a tree diagram for that situation, that works. But I can also just use these numbers to help me find how many options I have. So I have 2 sizes, I have 2 crust types, and I have 3 toppings. So I can just do 2 times 2 each time, that gives me 4 here, and then times 3, that would give me 12. I can just multiply these together. So 2 times 3 for my fundamental counting theorem. If it asks you to make a tree diagram though, obviously you have to make one. But to check your answer real quick, just multiply all your choices together. I have 2 options, 2 options, 3 options. Multiply them all together, you get 12. Okay, so that's how you would do a tree diagram to find out how many options there are. For example 2, this is pretty similar, but there are different requirements here. So you want to know how many possible license plates can be created if they have to have 4 letters that can't repeat and then 3 single-digit numbers that can repeat. So the easiest way to do this is write out how many options you have. I have 1, 2, 3, 4 that are going to be letters. And then I have 1, 2, 3 that are going to be single-digit numbers. So for my letters, there are 26 letters in the alphabet, and they can't repeat. So in this first spot, how many options do I have? I have 26 total letters that I could put there. We're going to be multiplying all of these together. So for the first spot, I could have anything A through Z. For the next spot, once I pick something, let's say this first letter is A, right? I can't use it again. So now instead of 26 letters, I have 25. Then for the next one, again, once I pick one, let's say I pick B, I can't use it again. So now it's going to be 24, and the last one's going to be 23. Okay, because each time I'm going down a letter. I already used it, so I can't use it again. Okay. Now for the single digit numbers, how many single digits are there? There's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10 single digit numbers. So I have 10 options for this first spot. Then for the next spot, we have to decide, okay, can I put 10 again, or am I putting 9 here? If they can repeat, that means if I picked 1 here, I could have another 1, and I could have another 1 again. I don't have to decrease 1 each time. The only reason I had 2 over here was because it is not allowed to repeat. I can't repeat it, so it has to go down 1 each time. Here, I'm allowed to repeat it, so it's just 10, 10, 10. Okay? Then from there, you're just multiplying all of these numbers together. It's going to be a really big number. So I'm just multiplying all of them together, and I get real big number, 3, 5, 8, 8, and then 1, 2, 3, 4, 5 zeros. So we've got 358,800,000. So a whole bunch of different license plates there. Okay. So again, just find out how many spaces do I need. I need 4 letters, 3 numbers, and then just multiply them all together and figure out if you can repeat, then just it's the same number each time. If you can't repeat, you got to go down by 1 each time. Okay. All right. Now we're going to talk, so that's fundamental counting theorem. It's just finding how many options you have. So now we're going to talk about permutations and combinations. They're another way for you to find the total number of options. So for permutations, the order matters, and for combinations, the order does not matter. So for example 3, how many ways can a camper choose 5 activities from the 10 available at summer camp? So it's not saying what order she's going in, she's just picking, like, I want to do arts and crafts, I want to go kayaking. So she's picking those, she's picking 5 from the 10. So the order does not matter here. So this is going to be a combination because the order doesn't matter. It's not like she's picking out a schedule. She's just saying, I want to do these things. Okay, so this is combination here. So the way that we do combination is first we want to write it out. I have 10 options and I'm choosing 5. So this is the way we write it. This is like a little subscript, little number in the front here. So 10 combination 5. So there's a formula for this. And for combinations, we say the number, and I'm choosing R of them. They just use N and R as the variables there. So the formula here is N factorial divided by R factorial and minus R factorial. Okay, so there's also a way to do this on your calculator, which I'll show you in a second, but I want you guys to just be comfortable with the formula. Okay, so this exclamation point here is called a factorial, and what that means is you're just, if it's let's say 5 factorial, you're just doing 5 all the way down to 1 and multiplying them together. So you're doing 5 times 4 times 3 times 2 times 1. That's what a factorial means. It just means that number all the way down to 1, multiply them together. So I'm just plugging in these numbers. So I've got 10 factorial up top, then R is 5, so I've got 5 factorial on the bottom, and then N minus R. So 10 minus 5 is just another 5 factorial. Okay, so what I said about the factorials is I have to write all of them out. So I've got 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 over 5, 4, 3, 2, 1. And then the second one, I have it there again, 5, 4, 3, 2, 1. So now remember, if I'm multiplying things together, I can cancel them out on the top and the bottom. So those all cancel. So what I'm actually doing is just 10 times 9 times 8 times 7 times 6 divided by 5 times 4 times 3 times 2 times 1. When you type that into your calculator, make sure that you are, if you're doing it all at the same time, which you shouldn't be, you should do the top, then do the bottom, then divide them. But make sure you're putting parentheses around it if you are doing all of it at the same time. So on the top here, we get 30240 divided by, on the bottom, 5, 4, 3, 2, 1 is 120. And then we just divide those two. This should always be a whole number because you're finding out how many options you have. And you can't have like 2.5 options for something. That doesn't make sense. So you need to always have a whole number here. So we get 252 is our final answer. So 252 is how many options that she has. Okay, so on your calculator, let's see if you guys can see this. Okay, so if you have this calculator or another one, there should be a button that says PRB. That means probability. You're choosing NCR. You need to put your number in the front. So it was 10, and then NCR, and then 5, and we get 252. Okay, so you can just do it in your calculator, but I just want you guys to see the formula and see how it works. So that's where it's coming from. If you are using the calculator that I posted the link to for Desmos, you have to go over to the probability button and you hit NCR, but you do the 2 numbers with a comma in between them. It's going to be like in parentheses 10, 5. So I'll show you. That would be you hit the NCR button and then it'll pop up with a parenthesis and you would do 10, 5. That's how you would type it in for that calculator that I sent you guys the link for earlier in the year on Desmos. Okay, and I'll link that again in the description for this video. So yeah, one more question. Okay, so how many ways can 10 people be elected to be president, vice president, and secretary of a club? So for this one, the order matters, because if I swap the vice president and the president, that's a completely different order, right? They have different jobs to do, so I can't just swap them around. Where here, if I pick kayaking and arts and crafts versus arts and crafts and kayaking, I still picked the 2 same things, so the order doesn't matter here. But here, if I swap around the president and the vice president, or the president and the secretary, that's a completely different club dynamic there. That's a completely different person in each role. Okay, so for this one, this is going to be a permutation. And for this one, I have 10 is my total, and I'm picking 1, 2, 3. So it's going to be 10 permutation 3. So for this one, the formula is a little different because it's a permutation. And then I have, so it's n factorial divided by n minus r factorial. So the difference here is the combination divides by the extras, that extra r there, and the permutation doesn't have that. So again, we're doing the same thing. So I've got 10 factorial divided by, and then I have n minus r, so I've got 7 factorial down here. So I'm going to have 10, 9, 8, 7, 6, all the way down to 1 divided by 7, 6. And then again, everything cancels from 7 down. That all cancels. So I'm just doing 10 times 9 times 8. And I get 720. So if I have 10 people running for president, vice president, and secretary, there are 720 different combinations or permutations that there could be there. So same thing for permutation. We're doing 10, but then we're hitting the permutation button, 3, and we get 720. Okay, so fundamental counting theorem. You're either making a tree diagram or you're multiplying your different options together. Permutations, order does matter. If you swap them around, it makes a difference. And then for combinations, the order does not matter. So if you swap them around, it does not matter. The order doesn't matter. Okay, so go ahead and try your homework for probability day 4, and then you are all done with all of your homework for the semester. You just have one more quiz left.